In the last lecture, we talked about fields and encapsulation. You learned how to write a getter and a setter. In this lecture, we're going to continue that topic and see how properties can help us achieve the same thing with less code. So what is a property? A property is a class member that encapsulates a getter and a setter for accessing a field. So why do we need a property? Simply for creating a getter and a setter with less code. So let's see how we can write a property. Here is the code we wrote in the last lecture when we were working with fields. So to recap, we have a person class which has a birth date field, which is declared as private. And we have two methods here, setBirthDate and getBirthDate, which provide access to this field. As you can guess from this example, writing these two methods for every field is a little bit time consuming and tedious. Imagine if this class had 5 more fields. We would end up with 10 accessor methods, and that's not really efficient. So we can achieve the same thing with a property. If we want to convert this code to use a property instead of 2 accessor methods, this is how the code is going to look like. So we still have the birth date field, which is declared as private. And here we have the property. Note that the property is declared as public, and it should have the exact same data type as the field. In terms of naming convention, we use Pascal case for naming properties. So the first letter of every word should be uppercase. A good way to remember this is whenever you're working with classes, you should use Pascal case in most cases. So the class name, the properties, and the methods, they all use Pascal case. The only cases where we use camel case is private fields, as you see here, which should also be prefixed with an underline. And another case for camel case is the method parameters. Okay, let's move on and look at our property here. So inside this property, we have a get method and a set method. Note that the get and the set here are C# keywords, so they should be lowercase. And they have a code block, as you see with the curly braces here. Inside the get method, we simply return the field. And inside the set method, we use the value keyword to get what is on the right side of the assignment and copy that to the birth date field here. Note that in this case, we don't have any logic around the birth date field. So our get and set methods are pretty simple. We can write even less code to achieve the same thing. That's when we use auto-implemented properties. So here is how we can declare an auto-implemented property. So we have the property declared here, public, datetime, birth date, and there is no field. We just have a get, semicolon, and set, semicolon. When C# compiler sees that, internally it creates a private field for us. So we don't have to do that. Okay, I think that's enough theory. Let's start coding and see all these concepts in action. Okay, let's declare a person class first. So public class person. We want to represent the concept of birth date for this class. So I'm going to just go ahead and declare an auto-implemented property without declaring a field. So public datetime, birth date, we open the curly brace, get semicolon, and set semicolon. With this code, C# compiler internally creates a private field and implements the get and set accessor methods for us. Let me show you how it works. So I'm going to compile this application. To compile, we press Ctrl, Shift, and B. So build succeeded, as you see here. Now, we go and right-click on the project. Note that here I have an item called Open Command Prompt. If you don't have this in your Visual Studio, you need to install Visual Studio Productivity Power Tools. It's an extension to Visual Studio, which makes coding a little bit more pleasing and easier. So how you can find it is you go to Tools, Extensions, and Updates. You go to Online, and in the search box, type Productivity Power Tools. There you go. Know that I have installed this plugin, and that's why we have this green tick here. So in your case, you probably have to click it and then you select download. You probably have to restart Visual Studio. Then you will get this open command prompt. And the benefit of that is it takes you directly to where the project is. Without this tool, what we need to do is to go to Start, open command prompt, and use cd / whatever to find that directory where the project is located. Okay, now I want to show you the actual code that is generated by the C# compiler behind this auto-implemented property. So first, let's take a look here. dir, we've got a bin folder. We go to bin, dir cd debug. This is where the compiled files or the assemblies are located. So take a look. Let me clean this up. So here we've got properties.exe. And the name of this project is called properties, and that's why we got this properties.exe here. It's an executable. It's a console application. Now what we need to do is we type ILDASM. That stands for IL disassembler. IL stands for intermediate language, and that's the target language that the C# compiler translates your C# code into. Any language that targets .NET Framework eventually translates its code to IL. In .NET Framework, we have a component called CLR, or Common Language Runtime. And what it does is, at runtime, it takes your IL code and translates that into the native or binary code for the machine on which it's running. So let's take a look at the IL code and see what it looks like. So with IL disassembler, we can here pass the name of the executable or the assembly, properties.exe. So here is IL deasm. Note that here is a namespace, properties. We expand that. We have two classes, person and program. Let's actually put this here. Okay, so here's our person class and here's the program class. I expand the person class. Note that here we have what is called a backing field. It's private and it's of type datetime. This is the private field that the compiler automatically created for us. And here we have two methods, get_birthdate and set_birthdate, which is similar to the code that you saw in the slides. And here is the property. If I double click that, note that it has a get pointer here, which simply calls the getBirthDate method. It also has a set pointer here, which calls the setBirthday method. Let's close this. Also note that here we have a constructor. And that's the default constructor that I told you the C# compiler creates for us. The job of this constructor is to initialize the class to an early state. So it sets all the fields of this class to their default values. All right, let's move on. We close this. I want to show you a few important things here. First, put the cursor here. Let's declare a property called age. So public int age. This property cannot be an auto-implemented property. Why? Because here we need some logic. I want this age to be based on the birth date of that person. So if I just type get and set here, internally the compiler would create a private field, and that age field will not be based on the birth date. Instead, what we're going to do is create a getAccessor method here, and here we're going to have some logic. So what we need to do is to get today's date, so datetime.today, and we subtract that from the birth date. When you subtract two datetime objects, you get a time span. So let's store the result in a time span. Note that if I hover my mouse here on the var, you see the data type of this object called timespan is timespan. And timespan represents a duration. So I can get time span dot days and divide that by 365, and that would give me the total number of years. And finally, I will return that. Before we move on, I would like to put this class in a separate file to clean up my code. So cursor here, Alt and Enter, Enter. Now back to our program class. So let's create an instance of the person class, var person equals new person. We set the birth date, person.birthdate equals new datetime 1982-11. Now let's display the age on the console. Console.writeLine, person.age. We run the application, 33. Now let's get back to the person class. Note that here in the age property, I just declared a get method. I didn't declare a set method, and that was intentional because it doesn't make sense to set the age of a person. The age should be calculated based on the birth date. So with normal properties, like the age property here, if you don't want that property to be settable, you just don't declare a set method. But what about auto-implemented properties? Let's say we have this requirement in our application that the birth date of the person should be set once and it cannot be changed. So how can we achieve that? With that requirement, what we need to do is to go in this property and put a private accessor before the set method. With this, if I go back to the program, you see this red underline here. And the tooltip says the property birth date cannot be used in this context because the set accessor is inaccessible. So then how do we set the birth date? We have only one place, and that's the constructor. So we need to create a constructor for this person class where we get the birth date and we set this property, and that's it. The property can no longer be changed. So let's declare a constructor, ctor tab. Here we get a datetime parameter, datetime, call it birth date, and we set the birth date property. That's it. Back to the program. We need to modify this code because now we have a constructor that takes a parameter. So I'm gonna select this code and put that here. And then get rid of the birth date. So let's review this again in our person class. We have two properties here. One is an auto-implemented property, which doesn't have a back-in field. This property has a private set accessor, which means it's read-only. You cannot change it. And we set that in the constructor here. We also have another property, which doesn't have a set method either. This property calculates the age based on the value of another property. What I want to emphasize in this lecture is you should make sure that your classes are always in a valid state. That's the key. Your classes should never lie. They should never be in a false state. In the example here, I have implemented this concept using a private accessor here and by removing the set accessor in the age property. So this person class, this person object is always in a valid state. We set its birth date, it cannot be changed, and the age is calculated based on the birth date. Okay, before we finish this lecture, I want to show you two more things. First, I want to show you a quick way to declare properties. And next, I want to tell you about the convention we should follow in C# when working with classes and their properties. So let's say we want to declare an auto-implemented property called name for this person class. So what I'm going to do is I go here on the top. Instead of typing public string name, curly brace, get set, I'm going to do a shortcut. So let's get rid of this. I just type prop, as in short for property, and press tab. That's a code snippet. Now note that the type is highlighted. So here I type in string, I press Tab. Again, now the identifier is highlighted, and I give it a name. And finally, I press Enter. That's it. This is much faster. Let me do this one more time without explaining it. Isn't that faster than typing the whole thing? So that's one thing. Now, another thing is in terms of convention, you might be wondering, where should we declare our properties? On the top, on the bottom, in the middle? Well, actually, I made a mistake here. This birth date property should be on the top. So what we need to do is we put all our properties on the top. Then we have the constructor. And note that there is a vertical space between all these properties and the constructor. If the code was like this, it would look a little bit squashed. It looked dirty and ugly. So always declare all your auto-implemented properties on the top, have a vertical separator, and then put the calculated properties on the bottom. Well, that's it for this lecture. I hope you enjoyed it, and thank you for watching.